Hi, ladies and gentlemen, this is Mr. Green. This is another in my series of recordings for AP Statistics. We're looking at Unit 9 now. Okay? This is the first study in Unit 9. This is going to go really very fast because there's not much in Unit 9. It is pretty much the same thing as Unit 8, except we're now dealing with proportions. Okay? So, a lot of you have been making up some work and you've been doing really good, so just keep at it. Keep making up that work. Get it all turned in because you don't want to have zeros permanent in your grade book. Okay, guys? So, we're looking at subtopics A2, A4, B2, and B4. These are confidence intervals and significance tests for proportions and the difference between two proportions. We're going to be looking at one proportion to begin with. That's what study 1 is about. One proportion interval, you define your probability, what you're taking the probability of. Your p hat, that is the probability that you've got. Okay, they usually give you a probability in the question itself, or they'll give you two numbers that you can find a probability. It's kind of like uh, the mu hat that you had before, or the x bar that you had before, but it's not. It's not a mean. It is a proportion at this point. Okay. And so we're going to use these proportions here too to get this error, okay? This margin of error, this plus or minus margin of error. It's this z value, not a t value, a z value now, times this standard deviation information or standard error that we get over here, okay? And since we don't get a standard deviation because we don't have a mean and we're not doing that type of a work, we're doing standard error, so we're going to use the probability and 1 minus the probability divided by n and the square root of it. And that's going to be our standard error that we're going to be using. Cool? Shouldn't be any problems with any of that. So, when you're doing a one proportions interval test, you always got to make certain telling how the data was collected using random samplings, however you want to. It's like those paragraphs that you need to make certain you're writing when you're answering these questions. You don't just give answers. If you don't write the whole paragraph out, you're giving incomplete answers, and that's what you're going to be faced with a lot in the AP test. So you want to make certain that you're getting them correct. The population, make certain it's at least 10 times the sample size. You're looking at n times the probability is greater than 10 and n times 1 minus the probability is greater than 10. That indicates that your sample size is large enough. So let's look at a problem here. Um, in a study of airbag effectiveness, it was found that there are 821 crashes of mid-sized cars equipped with airbags. 46 of the crashes resulted in hospitalization of the drivers. They want us to give a 95% confidence interval for the percent of crashes resulting in hospitalization and interpret the confidence interval and the confidence level. Okay? Well, the first thing I would do would be to say the probability P is equal to 46 divided by 821, right? That's what our probability is going to be here. And I'm needing to start up my calculator, so hang on just a second. So what I would say would be to say 46 divided by 821 or 0.056 or 5.6% of car crashes of mid-sized cars equipped with airbags resulted in hospitalization. And we want to create a 95% confidence interval for that. Okay? So I'm going back to this slide here. Was the data collected using random samples? Well, they found 821 crashes of it. We can assume that it's a random sampling of the data because that's not all of the data that would be out there. I'm sure there are more than 821 crashes based upon information that we all know and love, so that's probably not the problem there. Is the population big enough? Well, we want to take 10. We want to make certain that we've got 10 times the number here, so let's look at it. We're looking at 5.6% times 821, and that's going to be more than 10. I can tell already, right? It's going to be, it's like 46, obviously. And then if we take 1 minus 5.6, that's going to be a huge number, a lot more than 820 or than 10. So we're not going to have any problems with size on this one, right? So now it's a matter of using the calculator. And I'm going to come over to the calculator. I'm going to press stat. I'm going to go over to tests, and I'm going to go down to a 1 proportion z-interval test. And just went right by it there. It's number A, letter A there on my calculator. So I'm going to press enter. And it's asking for X. Well, X is the number that we actually were looking for. That's 46. And it's asking for N. That was 821. And we want to create a 95% confidence level, 0.95. And then we're going to go down here to calculate and hit enter. And our numbers are 0.0403 to 7176. 0.07176. So what is that interval telling me? It says that we would have a 95% confidence that uh, between 4 and 7% of the crashes occurring in mid-sized cars equipped with airbags would result in hospitalization. That's what you would be able to say. Okay? So, the next part of this question says, how large of a sample size would you need to obtain the same margin of error in part A for a 99% confidence interval? Well, this thing here, same margin of error. So what I'm going to do is I'm going to take 0.07176 minus 0.0403 and get 64130, that number right there, 3146. And I'm going to divide that in half. Why? Because I want to know what the margin of error was, that plus or minus value that I was adding on there. Okay? And I'm going to get a 0.01573, and that's my the margin of error that I'm looking to get to. That's the M that I'm looking to get. Okay? So, how do I find the 99% confidence level? Well, remember from the equations that we had and the stuff that they had given us. I'm going to go to a new page here. We were told that N would be equal to Z star divided by M squared times P times 1 minus P. Okay? Well, the Z star is the question that I would be asking. Well, since we're looking for a 99% confidence level, it's going to be a 2.567, if I remember correctly. We're dividing that by 0.01573, and we're going to square that number. Okay, well, I'm going to bring up my little calculator here, and I'm going to clear this, and I'm going to say 2.567 divided by 0.01573 and hit enter. And then I'm going to square that number. It's 163.919. And when I square that number, I get that huge 26,631. And then I'm going to multiply that times, and our number was, our percent that we were getting there was a 0.05. And then we'll multiply that, and I believe it's 503. I'm going to go back and look now. Didn't write it down. Oh, 56. 1056. 56. And then we're going to multiply that times 0.944. That's 1 minus 0.056. And when we multiply that out, we get 1407.84. .84. We can't have 0.84 of a situation we're looking at, so 1408. That'd be the number I'd be looking at. So that's what I would do if I were trying to calculate this all out. Does that make sense to you guys? Okay. Now don't forget that when you're doing this, you got to make certain you write that equation down. This one here, I copied it in right here. But over here, I actually wrote it down up here. Okay? Having that written down out like that is worth points on the AP test. That way they know you're doing the right thing. Using this value for the Z star. Okay? Showing how you got that M when I calculated it. Okay? Because I showed how I got that M. M equals this. Okay? Showing that work on the test is important. Okay? Dividing this, not showing that work there when this is simplified is not a big deal, but getting this number and rounding it to that number makes sense. Okay? Cool. Okay, so we've done that. I appreciate you guys when you send me information that you're telling me that you're in AP statistics. You're doing just great. If you have any questions, make certain you're coming to tutoring on Tuesday, Wednesday, or Thursday. That way I can help you there. And I look forward to seeing you